There we go. We are live, and yeah. Okay. I'm just gonna go ahead and like re-ult and everything because I have almost no idea what or like where anything is now. Okay. Um. Close that. First things first, I need to update the brain structure here. Okay, so never mind. I already do have a update. Forgot about that. So the brain update function. Uh, it's a third rank. Get void. Here we go. We'll do that. Update brain. Brain. Star brain. Update. Equals. No, let's do it this way. Yeah, no, that's correct. Because we have the void self, right? Yeah. How do I make good use of that again? I made all the name structures, but then I completely forgot how to. Time for some research. C struct as self argument in void. Pointer passing self reference as an argument. See, this is why it's been a hot minute. Blah blah blah. No, that's not what I'm looking for. Void call print. I guess it does seem to be this way here. Okay. We'll do void. Brain. You know what? Hmm. Assign function to struct. Maybe that'll help you remember. Hang on. AI powered? Yeah, why not? Let's generate. We're working on AI after all. Okay. Type that void. Yeah. It's kind of what I did. My function pointer, my function equals. Presenting my function type. So yeah, here we go. I guess I did it a little bit different. Okay, so that's an int, that's right. So then we have the value here. Then we call. Okay, but yeah, but that's calling it. But how do I define that function equals? The heck is that kind of format? That's interesting. So okay, we just set it to that. Yo, Neo, what up? Welcome to the stream. Hope you enjoy your stay. Okay, C structs, functions, arguments. Alright, AI is image. Never mind. Yeah, so we got that. Well, I get that, dude. I need to have it like an automated... Whatever. You know what? Let's do it this way. Three. Functions and structs, about the same. About the same, Neo, to be honest. Yeah, that's the argument. So, was it not self? Do you have to like do the well, no, because hey bub, like you and Bandy. You did. He's okay though. Hang on, net bay. Okay, yeah. So then we have the. Okay. Alright, so then that's all we have to do. Okay. So now we can safely go back to this, and if we just set the brain update function to update brain here, let's see, like a printf happy face, select them for a minute. Okay, yeah, and then we should just be able to define it this way. Rather than learning the literal in and outs of computers, I read some of that book of yours. I haven't gotten to chapter 2, but so far I'd say it's not bad. Oh yeah, the little story that I'm writing. Yeah, maybe I should write a book, actually. Like a book on programming for ADHD. It'd be kind of interesting. Okay, will this generate an error? It does not. Excellent. By the way, there is a lot going on under the hood. I mean a lot going on under the hood. Oh my gosh, like, dude, this, like, we're running a TCP server so that we can actually control all the functionality from a web interface. While the C code actually does all the processing, so it's like lightning bolt fast. I could have used like WebASM for that, but I didn't feel like learning how to like compile C things for like this complex for some WebASM. Okay, so yeah, now we know that that's kind of working. So now in the lifeform .c, I need to make void update lifeforms. Oh, and I need to properly define this as well. How to focus on computers for ADHD people. Yeah. Although the entire book would just be like 2,000 pages long, just saying you don't. Yeah, RNG, random number generation. We're actually using some here. How many inputs and outputs should we have, like a max? Let's do like 15. No, Yeah, why not? Let's yeah, screw it. That's a lot though, so I'm just gonna shrink it down a little bit. Well, my friend, the one I'm playing D&D with, uh-huh. She said if you roll a D23, then she'll go out with you or something. It's fine. Okay. Yeah. So now, oh, crazy because he didn't get the Pokemon. And the bot runs RNG. Wow. Like, dude, it's just a game, bruh. I say as I, like, slam control enough. On that back. No, I didn't use on hold because right now I don't know. I'm down a player. Oh, just make it so that, like, just adjust the storyline so that he died or something. Like he had a massive hemorrhoid that like stopped him. Well, stop. We're not doing that. Okay. They'd like ones. Yeah. Now what I want to do is here. We have like a light form count. Okay, hold on. See, get size of pointer. Here. Okay, size of x divided by what? Okay, you know what, AI? That's okay. Size of around pointer. Huh? See his size of pointer. What happened to the AI? He's kind of a little OP because of his ability. Saying let him some Sway to protect. Dang. Okay, you know what? I'm just gonna look at the way that I I don't know why I didn't think of that. The way that I allocate things. All right, so yeah, great brain. And in the brain, yeah, neurons, star neurons. What's that? Malik size of neuron times neuron count. So like Okay, yeah, but that's always going to be like a 4. I need to know the length. Data type. Yeah, there you go. Yeah. Yeah, I get that. Is it really just that simple? I'll find out. This seems to be healthy, right? Yeah. I don't think I'm doing anything with the lifeform array, am I yet? Am I? No, that's right. I swapped things up here in the TCP section. Okay, process lifeform request. This will do. Yeah, that's right. Okay, yeah. Response buffer, blah blah blah. Lifeform count is. Okay, yeah, we do have lifeform count. So where is it? Is it in controls? Oh, it was in controls. Yeah. Okay. Yeah, duh, yeah, because like the lifeform disconnected. Alright. So then I'm gonna move yeah. So I'm gonna move update lifeforms function into here. Yeah. Lifeform LF link update equals. No, what am I doing? Let's do. We don't need that many lifeforms. It's less than lifeform count blank. What is this JavaScript? I++. And is it really again? Dude, I keep having audio issues. Why now there's like a bunch of static, right? What the crap? I think it's it might be because like the hold on, this should be like a lot better. There. That's a pain in the neck though. I can't. One sec. It's over here. Okay. Right there. Okay. That should be a little bit better, but honestly, I don't know. Maybe the gain is set too high on the amp. Or audio UI. Yeah, maybe. But like OBS is so it's like OBS is showing that it's normal, but it could still be clipping. Let me adjust. Hold on. Turn the compressor up. Where is it? There it is. Turn the overall volume down. Okay. So that's better. Ah, thank you.
I'm gonna bring you some vegetables here soon.
Oh heck yeah, thank you. Oh, that smells so good. Hey, we still got the Carolina Reaper cheese in there. Ah, we ran out. That's good cheese, man. Um, damn it. My dad just brought me some chili. Yeah, so we had this like Carolina Reaper cheese. And stuff was so good, dude. And yeah, you can get it. You can buy it in Stallings. Mm. Okay. Yeah. For some reason though, Crimson, like whenever I get it correct, like then like when on the next reboot it won't be correct. But I'm using an XLR mic, so it's always being like it's always like going through a mixing board, which doesn't change. So I have no idea. I gotta keep on. I gotta like tweak the settings almost every time for some reason. I don't know if it's like interference of some kind. You want a fan of jalapeno? Oh, dude, jalapeno is good. Okay. Okay, yeah, it's a point as well. Uh, it's gonna give me an error. Yeah, I thought it would. What do you mean? Do we not need to pass that? Hmm. Hmm. By the way, maybe your mixer is you can find it's old though. Yeah, it is. It is pretty old actually, but. Hmm. If you want to look at it, I have a premiere on Thursday of Borderlands. Yo, that's hype. I'm so mad about my new software to record everything again. Cut off 10 minutes of the ending, jeez, dude. But yeah, let's see. Yeah, waveform display, waveform array. What am I doing? Yeah. Yeah, that's what I'm doing. But do we not need to do a do we just need to do it like that? Oh, cause the brain itself is the pointer, not the yeah. Wait, no. Yeah. Huh. Now I don't know if it's gonna automatically add the argument. I didn't think it would. 2p yeah, okay. 2p arguments in the function, but it's there. It's recognizing a function. Excellent. Array what? Waveform array I dot brain. Now it should just spam a bunch of nothing. Never mind. Oh yeah, because we're not actually calling the function. Okay, so in the main.c, in a CPU loop. Which I believe was in here, right? No, it's not. Where did I put that? Not in render, is it? No, I didn't think so. Render is still empty. I'm actually probably gonna remove renderer. Okay, main.h. Where is the CPU? Links.h. Oh, was it in TCP? I think it is, yeah. Yeah, I think it's like, no, that's the TCP server. Okay, hold on, I need to, you know, as organized as this is, I still, what's it in CPU loop? Oh, yeah. Okay, I'm actually going to remove that function for now because the CPU data thing isn't working at the moment. Mac OS? No, I'm using Linux. In particular, Fedora Linux with the Sway FX desktop. It's snakesy. You're lucky he wasn't doing a story at the point? Yeah. I feel like it would have cut off the... By the way, this is how the AI is gonna work. I don't remember if I like fully explained it here yet or not. Yeah. Sorry. Okay. I'll just give you to TLDR version. Instead of using like traditional weights and biases, this uses a more, it's like a hybrid of genetics kind of and weights and biases in a way. So basically, instead of just those values for weights and biases, each neuron has its own function, and depending on, here, let me open the neuron. I was using different software on my phone. Got you. Okay. Where's my neuron? All right. So this is the neuron struct. Okay, we have input nodes and output nodes. And we have like these here for the counter because yeah. So when we also have a favoritism. The favoritism, basically each neuron has a unique ID to it. Well, the input and outputs do, not the neuron itself. And the favoritism for the neuron, like, so okay, how do I explain this? The favoritism acts like a multiplier for how excited the neuron gets when it's receiving a signal from like this type. Basically the favoritisms all, it's like an array that has the ID here. I still need to program it, but anyways, so that, in other words, like if you have a neuron that is telling the life form, if you will, to like move forward, depending on how much it favors the previous or the connecting neuron. So if you have a neuron that says look, like when it looks around and it sees something, depending on the favoritism, general quality, and the connection qualities between the wire efficiencies, the excitement of the moved neuron will be different. So that opens up a sort of like, okay, that's a bad idea, I don't want to go over there kind of concept. Or it excites the neuron and it makes it want to move there more. That kind of thing. So yeah, it's pretty cool. There is a lot to it. Matter of fact, since we're here, I gotta go ahead and code that here. Yeah. For unsigned int I equals 0, I is less than I plus plus neuron dot favoritism I equals 1 plus rand percent well. Should work. That's not gonna throw an error, is it? No. Okay. So yeah, basically what it means is this AI has the ability to become lifelike, ideally for video games, like for having unpredictable, like AI generated worlds entirely. Like using this method, you can actually have it develop hostile enemies or NPCs at a village. Like if you wanted a farmer, I always use this analogy here. If you wanted a farmer, well, I guess just tell it to farm. How can I explain it? Yeah, okay, so randomly generated villages. You're gonna ask what this purpose is. So like imagine a game where the world's always different, but you need quests, you need like storylines, and you need you want, you know, functional villages that are just randomly generated, but you don't want to have to define what type of villagers live there. RNG based environment, kind of. So basically, depending on whatever training data that you're using, it'll know what to do. So like if you train a villager type to farm, then that villager will give you dialogue based on the farming, like based on farm related things, or even potentially give you a side quest. But it'll also tend to crops, and it'll go inside and outside, water, it'll do all the stuff that it needs to do autonomously. Like you don't have to code it to do so, provided you have the training data already available. So that's one use. So like you don't have to define the shops as well, like automatic shops, like living NPCs basically. So no one knows how friendly they would be. No one knows how smart or stupid they would be. So that's one. And then you can like use this method as well to create enemies that are unpredictable, like wildlife in a game. In a way, Stardew Valley mixed with Minecraft, where, well, that's just one analogy of it though. It can be used for a number of things, but in this explanation, I'm kind of using video games as a like as an example. But yeah, so creating, like, simulating wildlife on an alien planet, right? This will automatically be able to generate both friendly and hostile style enemies. Yeah, and not just that, but like it'll be able to generate a lot of stuff. I don't know how to explain it, but yeah, it's an AI that is capable of randomization in the sense of like each thing has its own unique brain structure to it and intelligence. Yeah. Yeah, it's gonna be really cool. I've been working on this for, like, this concept anyway, for a long time now. And I'm not, like, it's part of a challenge, so I'm not really, like, I'm not gonna be looking up any tutorials, like, on the whole weights and biases thing for your projects. Yeah, kinda. But it's gonna be open source. I think I had a Git repository for the old method. Yeah, like, hold on, let me show you how many iterations this has. Tunar. Projects, AI. So 1, 2. This was when we were using JavaScript for it. All the and then I tried using direct frame buffer to like visualize everything. AIS was like a little thing that I was developing at some point. Yeah, so there is, and I tried C++ as well. Dude, there were so many iterations. I think I even have some, yeah, AI node when we were using Node.js again. Not very organized, but yeah, there were a lot. Open course. Yeah, no, it'll be open source. At least the opening concept will, but like advanced training methods and stuff, that'll depend on whoever the F, like that'll depend on whoever wants to define it. But I'm hoping to have like a website as well where like people can submit their training data, and like people can download that said training data to generate the AI things. Okay, so now where's let me see here. I want to create a hold on. I have an idea for the update thing. Yeah, let's do it this way. We're gonna make a P thread for the update. I make my own stories for everyone, but I can see how useful that code can be. Legit though, even the Yankee shard. Well, yeah, that's how it normally is, but like this would ensure that every time, like for example, every time the player would begin the game, it would always be different. Okay, I want to actually divide the updates between the amount of p threads. So we'll say, yeah, all right. Type def struct p thread updater lf and call it unsigned int start, unsigned int end. Struct p thread updater lf. You know what? I like this kind of styling a little bit better. Th. Yeah, we'll just call thread. Thread equals p thread updater lf star. And then it should just be, I think. I know I had some like p thread stuff that I was playing around with earlier. Yeah, here for example. Well, I did. Apparently, I'm not getting any of the arts. Okay. I think I was doing this here though. Yeah, I was. When I was like attempting to make p threads process the TCP server that we're going to be using to get and receive visuals and functionality. Sound good. Hope to make it into what you want. Thank you, I appreciate that. I'm not giving up on it because I am stubborn with this. It took me a while though to like, yeah, to be able to like, well, no wonder that wasn't working. Huh. Is that really, did I get rid of them? Oh, here we go. Yeah, okay, it's just that. And then Hard. Okay. I don't know why I couldn't remember how to do the pthread thing, like, off the top of my head. So the pthread is basically multi-threading. Uh, and what we're gonna do is void start updater. Wait, start live form updating. Updater. What was that accent that I just did there? Pthread t thread. Ooh, actually, hold on. Yeah. So we can do index and then thread count. We'll do it that way. In my main.h, do I have... Okay, maybe it's in... No, I didn't define the database h either yet. Here we go. Get nprox, CPU count. I'm just gonna grab this. For let int I equals 0, I is less than nprox I plus plus. Yeah, that way. Format it, clean things up. Playing that theory that every Pokemon game is a small and different dimension based on who is playing. Seriously, that's a thing. That's pretty cool. Yeah, hey, good luck, man. That's awesome. Oops, what am I doing? Yeah, is the get nprox thing... What type is that again? Okay, yeah, okay. It is an integer. I thought it was. Yeah.
I do want you to eat this, man.
Okay. Heck yeah.
This is good for you.
Oh, heck yeah. Hey, that's from the garden. Some of it.
Some,
Oh, that's awesome, dude. Yeah, it beats grocery, like, store-bought stuff, sure. Woo, hot. Okay. I'm gonna let that cool down. Alright, now, yeah, int len equals len, just do len. Oh, I hate how, like, the formatter adjusts the things down here, though. Like, I'm not used to that kind of... Ugh. Ah! Oh, well. Like, I prefer the thing to be here, but... It's not, like, that bad, I guess. Okay, threads, yeah. So pthread creates, I believe, yeah. And this is a pointer. And then we do the function, update life forms. No, we do null first, yeah. Then update life forms. And then we do the arguments. So we need to do pthread temp equals, and then I, and then the len. Yeah, it should be a void star and then temp. Yeah, there we go. Okay, so this would be I is going to be set to int index equals thread index. Am I doing that right? Where's my info density? There it is. Wait, was it not here? I got lost again. Where? Okay. Whatever, we'll try it. If it throws an error, it's gonna throw one, but man. We need to JS doc this as well. Multi-threaded Lifeform update system. Creates multi-threading for updating lifeforms. Okay. I think this should just straight up work like that. Oh well, we'll see. We'll see. And it needs to be unsigned. You know, we don't even need the yeah, we don't even need to do it this way. Yeah, we can do this. C pass int to pthread. Just as a reminder. I'll make sure I'm doing it right. Look at me using an AI to like code AI. I would use ChatGPT, but that's like cheating and I don't want to do that. Yeah. So, oh, okay, we just do I, and then we do, huh? Well, that's very interesting. Huh. And then we'll do while 1. And then sleep 0. Instead of sleep 0, actually, let's do a, well, I'll do that part off screen. No, I'll do it now. I was gonna go ahead and make this even faster by like having a, like letting it do as much as possible within a 16.6 millisecond time frame, and then temporarily break the loop, and then sleep for 0. But it couldn't matter too much. Alright. Equals len divided by thread. I think it's supposed to be like that, right? Oh. Okay. So I would just, I'm just gonna feed it the whole dang thing here. So this should work. Yes, the code you provided should work. The update lifeforms function will be called. Oh, that's pretty cool. On a separate thread. Okay, that's really smart. Well, I guess it's obvious, but in the lifeform array. For each lifeform in the lifeform array, the brain up. Oh, it's close, but I mean, I only gave it the one function. How does it know? This is amazing. an event that will be called on each life form to update its state. Here's a more detailed explanation, blah, blah, blah. That's pretty awesome, dude. No, you're good. I need to get away from the AI because otherwise I'm gonna want to like cheat because that's freaking amazing. Oh yeah, we this just needs to be I. Here we go. Huh? Unsigned. Oh, what? What am I doing? Start. I is less than. Yeah, we'll do end equals this. Yeah, divided by 1 plus that. And then this needs to be a modulo of life form count. No, not a modulo. We need to do max or the min. Okay. Yeah. So we'll do minimum. So like this is the smallest that it can be. It'll wait, it's does C support min max? If I remember right, it doesn't. You know, like you need a well, I'll just like this. Alright, don't mind if I slide into these DMs and then put this in my not links.h because that is generated. That's max. Oh, there you go. I totally coded that myself because how does this work actually? Hold on. Yeah, okay, so we have well, I need to min man. Okay, yeah, so we passed the argument there. And we'll check. Okay, yeah, we're checking to see if it's we're basically doing a ternary operator to check for if A is greater than or less than, and if it is, return. Okay, that's simple enough. I should have thought of that. Oh well. Okay. Yeah. Okay. So yeah, that should max it out here. Yeah, okay, and then we can't divide by 0, so I need to do I plus 1 for that. Yeah, okay, that's perfect. Do I need to add this by 1 as well, though? Alright, we'll find out. These work. It didn't work. Okay, oh, yeah, because, the controls.h. Let me define it here. Nani? Lifeform.h. Oh, yeah, I forgot to remove from that. And this. Control.h, Control.c. I'm just gonna okay, now we need to go to the main.c. Do you see my machine? And I need to call the function. So instead of an CPU loop, we're gonna do start lifeform updater. Updater. Don't be a hater. Alright, so now it should just spam us with happy faces, but it does not. So we got a segmentation called instead. And I think I know why. I think the AI was like lying to me when it comes to this. So int thread equals int star args. And instead of that, what? Oh yeah. Okay, well, we're not getting a segmentation fault, but it doesn't seem to be updating either. Printf function. Wait, updating happy face. What? Anyway, I'm actually about to end the stream. But yep, there we go. All right, it is updating all the life forms. Short series, 2 of them. One explaining the life and stuff of Pokemans, and 2. Yo, that's pretty cool actually. Kind of reminds me of a Mystery Dungeon. Which I actually barely played. Like, I've seen it. I've seen people play it. But, okay, I need to print out, oh. All right. I agree. Gardevoir is super hot. I mean, what? I have a fairy or a psychic. I would say like fairy because like I feel like an Alakazam should be like the leader of psychic. I also feel like Hypno should be driving a mysterious van offering candy. Not sure which might be better. Oh, I already read that. I'm assuming. Alright. So, this is working. It is indeed, in fact, working. So my brain.c. Brain.h. Alright. Yeah, update brain self is not working. Alright. Does it need to be like that? Let's try it this way then. Yeah, we'll just call the update brain function like this and then pass that. Now it should spam us with a bunch of happy faces. It's not. Why is it not? You make them all seem. Okay, so but we do know that this is working. Yeah, no, that should be working. Let's get this only once real quick. Yeah, 100050. Um. So the issue here is, not because like, is it that? Does it? What's gonna happen? It's gonna try and divide by 0. It's gonna throw a segmentation fault, right? Oh, floating point exception, yeah. So that's not it. You know what? Okay, we'll just have like one thread, for now. Process it? No, we don't have to. Okay. Okay. Let's do. Oh, these need to be unsigned. Oops. Yeah, so we have our start, which should be the result of the length, so the processor count divided by thread. Yeah, because that should. No, it isn't. Okay, so what we need to do. My brain hurts. Yeah, I'm just gonna like do one p thread for now, and then I'll figure the rest of that out off screen because I want to see. No. It's gonna bug the F out of me. I have to do this. Okay. All right. Time for some math. Okay. So, if our core, we have 16 threads. Okay. And there's only 5 life forms. We should do the start would always be the life form count divided by the thread index. No, but divided by the thread count. And then times index plus 1. So yeah, that would be okay. That's what it is. Okay. Life form count, thread count, for in this case len, times index. It's going to be called index now. And then this one is going to be that plus 1. And then life form count. Maybe? Oh, hold on. No. Okay, now I got it. So it's index divided by thread count times life form count. And then this should be index plus 1 divided by that. Yeah, there we go. So now they're going to be updating however many they need to. Welcome back, Juan. Welcome back. Yeah, okay. So then that's gonna make it so that they update everything they need to. Thread percent the LD. No, C. Will be updating life forms. Wait, is okay. So instead of like just printing this, I want to actually do x1b. We'll see. We'll do for the y position. We'll do index. Percent d. And then for the x position, we'll do just 0. H. Yeah, and then index. So basically what that's gonna do, yeah, so now this will always be like updating here and stuff. Zero's updating. However, we have a pointer issue. That's okay. Yeah, we ended up with a segmentation fault because okay, H, which means that we have something wrong here. Which that's fine. I can always. Okay, yeah, here we go. Min index plus 1. Right? Yeah. And that should fix our segmentation fault. Yep, there we go. However, the value is still off. Unsigned. So why is it off? Why is end like, huh? Is it just a pointer issue? Yeah, no, it is. This isn't good. Where's the memory leak though? Swap register A1 with FF? I would, but the way my A2's set up. You know what? We'll just do start plus start. And then with a maximum of life form count. Why is it still like that? Red 0 is updating life forms 0 until. Yeah, no, that's correct, dude. Why is end returning? See, like if we do it this way. What is that? Okay, hold on. Let me do printf x1b. Oops. 2j to clear the console /n. Make sure that Not sure enough, dude. What is that? What's causing the memory leak? Because again, like we're not. Huh. Is it the minimum function? No, because that's very simple in how it works. Yeah, we're getting a segmentation fault again if we try a max, because it's gonna go like beyond the life form count. So no, this is being set. Is it really that? Does setting the cursor position actually impact it? It does! Huh? Was it like not a capital H? What? Huh? Why not start? Start. Because that would require stripping, and I'm not about to strip. I don't know how that makes sense, but... Okay, does it also do it if I just straight up say 0, 0 for the cursor position? No. Huh. So it's only the digit. Integer? Do we need to do like an and somewhere? Because it's a pointer type? I don't think that's gonna throw a seg fault. No, it just won't work. No, the index wasn't the issue anyways. So yeah, the index would be I plus 1. So why are we getting a bunch of zeros for the index? It's not, okay, so it's not processing this. It's ignoring that, so printf index. I think we need to like move to the index first. It's gonna be like a line down, but huh. Wait a minute. Oh, I am dumb. This also needs to be indexed. Okay, I was wondering. I was like, wait, there is no memory leak, so what would be happening? But no, it's that. Yeah, no, we're good now. However, I need to clear the thing, so I guess we will also do, after the move line, we'll do x1b 2k, I think it is. Yeah, so that clears it on the right. So now this is always going to be updating to the amount of life forms that we have. But because, yeah, so technically only one thread right now would be updating them because we only have a total of 5. And you can't like divide 16 into 5. So like if we increase the amount of life forms that we start with, let's say like 45. Yeah, initial size. Oh yeah, no. So that's just the initial size that we add for like safety. Let's do 1 here then. So where's our main.c again? Here it is. Okay. Let's do 35. 35 random life forms. Now, there we go. Nope, that is incorrect. Why are you like that? Okay. Control C. So then, what would be causing? Let's format that. What would be causing? Okay. Yeah, so we have our index divided by the thread count multiplied by the life form count. Maybe it is this? Life form count divided by thread count index? I can't math right now, dude. Yeah, no, that just gives a segmentation fault because it's not gonna... Wait. That's okay, Neo. I'm actually about to end the stream as well. It looks fun. It do be. Okay, so there we go. But then now it's right back to... Okay. Huh? Okay, I'm confused. Isn't it this though? Life form divided by that times the index, right? How is it not that? Okay, so again, let's do this then. We have 16 threads, right? And we have 35 life forms. Oh, I mean, I guess that does no. It should divide them in between the circumference of a hooker. Trying to debug a .NET project so it can run without depending on VS. Have fun with that. Yeah, because .NET pretty much relies on Visual Studio, unless you like hijack the interpreter slash compiler and like steal its main functions. You can do that with Ghidra, but it's a major pain in the nuts, dude. That's true. That's true. Okay. Okay. Var t equals 16. Var l equals 35. So what would t divided by l equal? Yeah, that. And then times 1, 2, 3, 4, 5, 6, 7, 8 times 16. Okay. No. Okay. I divided by total and then times L. That's not going to help us because that's going to... Okay. How about I divided by L times T? T divided by L times I. Yeah, it should be that. T divided by L times I. So the thread count divided by lifeform count. Yeah, times index. That's how it should be. So why is it not? I broke the shell apparently. Huh. Before I do go, I want to try and figure that out. Yeah, we have our index. Well, since we're not divided by 0 anymore, I guess that would be the issue there. I shouldn't throw a segfault this time. Huh. Oh! Yeah, that needs to be here every time. Yeah. Huh? Maybe not? Hold on. Yeah, no, that's still correct, yeah. But it's still 0, 0. Why is it still 0, 0? Why is start and end 0? Okay, let's try it this way then. Yeah, okay, let's try it this way. Thread count divided by index. Yeah. Times. Am I just overthinking this? Hold on. Yeah, because if we do light form array, the length of it, or light form count divided by the amount of threads. So time, yeah, and then that should just straight up be like that. That's why is that returning a 0, dude? That absolutely should not return a 0. Now we're getting a segmentation fault again. Why? Okay, max 0. Max 0. We're still getting a segmentation fault for that for some reason. Is it because these are unsigned? Like, I don't know why that would be the case. No. Okay, let's try this. Index times. We do before a little bit different. So we'll do index times, which should start at 0 here. Divided by thread. How does that not work? That should work. Why is it throwing a seg fault? Why? What? Huh. Because, like, index is going to be 0, right? And we have the life form count, which at the moment is 0. So 0 times 0 is always going to be 0. What are the right count? Is it because... Okay, hold on. I think I have an idea. Max 1 and then life form count. So that way it's not dividing by 0. But it didn't give us a floating point error though, so it's not that. It gave us a segmentation fault, which means I don't want to use DBG, dude. Like, that is gonna be a pain in the nipples. Okay. I guess what I need to do is comment this out real quick, and we'll do index life form count yeah, percent D, percent E, percent D. Yeah, so we have index life form counts, we have we already got the index thing. We already know that that one works. Thread count, and then well, heck, we'll just do that. Okay, we need to find out why we're getting a seg fault. Yeah, so the life form count is indeed 35, and the thread count is indeed 16. So when we divide by the circumference of 1, all right, so 35 divided by 16, that's going to be, yeah, 2 point, Alright, and then we multiply that by the index, right? Yeah. Times 0 is going to be 0. And then times 1 is going to be that. Times 2 is going to be that. So why does that throw a seg fault? Our life, okay, both lifeform count and thread count are standard integers. And the index is without a doubt 1, right? So why does doing math in that region cause a segmentation fault? Why is that one changing from 0 to 1 so fast? Oh, yeah, no, because, yeah. This needs to be index plus 1. That's going to throw us off. We need to go ahead and fix that. Okay. Yeah. So, what the heck? So now let's try let's try the operation here. Okay, let's do I. Lifeform count divided by thread count. Yeah, that should be 35 divided by 16, which should be floored off to 2. Yeah. Now, if we multiply the index of that, it should be 0, and then it should be like 2, and then so on and so forth. Yeah. So then what's the issue? Where's our seg fault coming from, dude? Okay, int start is going to be equal to that. So now, instead of this, we'll just say start. Yeah. And then the end should just be the same, start plus the same thing again, sort of. And it should be 35 or 34. No, it's not. It's, oh, yeah, this needs to be times index plus 1. Or heck, just start plus 30. No, that's gonna be 30 and 32. How many life forms have we created again? By the default? Oh, it's right here. 35. So we need to use the seal command. CEIL. $32 still. Huh. What'll that do for us? 34. Huh. Yeah, and it starts at 2. Doesn't even. Oh, I think I see it. Yeah, so that needs to be a +1. The thread count +1, and then. You know what? We'll just add these up here. So we're not like continuously generating them. Huh? Why? PC. PC. Yes, like at the start. And, what am I doing? I can just do. That's still gonna do that. Huh. The index is still gonna be like that. But even if we do increase that, it doesn't matter because it's still gonna. Alright, let's turn these into floating points. Let's actually not turn them into floating points. Does the life form count need to be subtracted by 1 as well or something? See, that's it, dude. 15, it ends there. But 16, the thread count's supposed to be +1. So why is it not being +1? Because look, thread count is now reporting 17 for some reason. Huh. Okay, yeah, we got our index. What am I doing? No. Oh, never mind. Yeah, so we're gonna index +1. We got our index, which is, it should be, like, okay, yeah, 0 to 15. Yeah, and then the life form count is 35. Thread count is showing 17 for some reason. But it's still not properly doing anything. So why? Yeah, because the start would be 0 there and then 2 there, so yeah. I am confusion. I think it's because, like, we're not, yeah, I know what's going on, okay. So, the len needs to be +1, so we need an extra thread for some reason. Which it doesn't matter, I mean, yeah. Why is it not applying properly? Because that shouldn't be 34. That should be, like, rounded up to, okay, so I think what we gotta do is, because these are, like, floating points, so we need to turn these into floats. No. Yeah, int float. That? No, that's still not gonna properly. Okay. Okay. I get it. I get it. I get it. Let's make these floats for now. Instead of seal. We'll do round. No, I think we do need to seal. And then %F for floats. Okay. What? Oh. Yeah, look, it's like... Hey, what are the actual values? It should not be like that. Am I missing another thing? Nah, because, like, look, the thread count is showing 17 for some reason. Okay, that should not be rounded at all. So what's happening? start and end are the floats. Yeah, and then like, huh? Okay, so like this is what it should be. So we'll do the life forms equals that, and then like threads equals yeah, 16. So this is what it should be, dude. Hold on, not that. Huh? Huh? Yeah, so this is what it should be. Minus the infinity part. 35. No, that's incorrect as well. Okay, I think my brain just shat itself. Alright, let's do LC like we did before. Okay. Okay, yeah. Life forms divided by thread count times I. But why is it like that? Because, yeah, if we do one more, it shouldn't be 34. It should be straight up 35. Plus, these floating points should be that as well. Yeah, we got our index, life form count, thread count. Oh! Yeah, duh. Alright, so now we're talking. We need to turn all of these into floats by doing this. That's a temporary solution. There we go. There we go. Yeah. So now we can turn these back into INTs and then convert all of that into an INT, which it should automatically be, but still, I'd rather be safe than sorry. All right, let's see what these show. There we go. Hey, man. All right. All right, so there we go. Now, all the brains are probably going to be updating with the proper count. They shouldn't have a segment fault, but we do. Why do we have a segment fault? INT I equals start. I is less than end. Okay, we'll do this. If life form array I not equal to null, let's try that. Yeah, okay, so it is a void. Let's just say if it exists then. But no, that's gonna cause an issue later on anyway, so we can't do it that way. Well, we'll just do it this way. Oh yeah, no, because like the 34th index. Duh. No, because now it's gonna segfault because it's gonna try to access a 0. Huh? -1. Question mark? No. Okay, so if it's less than n-1. Huh? Okay, why is there a seg fault here? That should not matter. Is it like converting them back into that? Skipping a segfault? Creating a new... Okay. It's definitely the for loop here that's creating the segfault. But why, I don't know. It's... Well, I do know, but I don't know how to fix that. So let's see. I love it like an hour ago. I was like, okay, I'll be ending soon. Is it just the reading of this that's, No, I didn't think so. Also, let me move I out of here as well. Okay, so let's do printf. %d / n. And then the value should be, where's the brain? Yeah, brain.h should be neuron count. Life form array I.brain life form count. If that does a segfault, okay, so it's not doing a segfault, but it is, however, hold on, maybe not. Yeah. So it is, in fact, a pointer issue here. Do that? No, okay, so it's reading beyond the lifeform array thing. So let's do size. This should always show a 4. If we do the size of. Or a 16 in this case. Okay, there's the brain.c. Neuron count. But why? I think we do need to create 10 dummy life forms first. Or more. No, that's not gonna matter. That shouldn't matter. So what's the issue? Your life form star Malik. Yeah, initial size. Actually, we don't even need to redefine that. So yeah, we do the, okay, the push thing. Yeah, temp LF. Okay, I'm gonna add a... I'm gonna pull this thing down. Alright, I'm gonna add something to the lifeform display struct. Form length. And LF link, neuron count. Okay, so then that does, yeah, this, and that jumps to this. Yeah, no, that's required for that. We don't need those. Huh. Okay. Has something to do with this part. Yeah, that's the anode. Oh! Which has the proper values. Why did I do it this way again? Oh, yeah. No. That's why I did it like that. So yeah, this creates the temporary life form array. So I need to rename temp LF to temp LFA. So I don't get confused later. Okay. Anyway, I'll end at the 2-hour mark, regardless. Hmm. Um. Yeah. And that creates that. Hmm. Okay. Well. Yeah, life form display stamp. Life form count -1 equals a new life form. Life form a new life form equals. Is that accurate? Hold on. Yeah, X, Y. Okay, I want to make sure that they're all 32. So I can debug this a little bit without having to use like DBG. I don't know. I don't have an issue with using DBG, but like I'm not too familiar with it. I don't really want to spend an hour trying to figure that out. I don't know how complex or easy it is, but okay. And I want to use the P threads to update everything because. Yeah. Okay, so this should always be 0. I mean 32. Yeah, it could just be dot. Yeah, it should just be. So if it's not a 32, it's because we need a what? Clarify it. Life form has no member named X. Oh yeah. Okay. That's not gonna do us any good. Life form display I dot X. Yeah, so those are 32s. Okay, so now life form brain update. This should just return the same number across all the results here. Okay, yeah, it's gonna segment fault us. Size of. Yeah, so that's gonna be a 0. That should not be a 0, but do we need to just not use a arrow pointer? Yeah, no, I thought we did. So that update. Yeah, that also needs to be an arrow pointer. Okay, so it does recognize that it's there. So that's also a 0. Okay, well, let's try it that way then. Yeah, we're getting a seg fault again. Huh. Oh! No, that's still gonna result in that. Okay. I'm just gonna try this one more thing, and then we're gonna call it for now. Yeah, and avoid a big rain. Too few arguments? What do you mean? That is not true. Oh. They're like, let's not pass an argument. Nah, it's still gonna seg fault. Okay, one more thing. Yeah, alright. I'm done. What, using the code? Oh, Darklight, welcome to the stream. I'm using Visual Studio Code. And, it is free. I will send you out. What? Okay, VS Code. Benji's bored, ain't he? Well, the web page doesn't want to load, but there you go. All right. Anyway, thanks for watching. Bye, guys.